Good morning, Algebra 1 students. This is Mrs. Anspaugh, and I am here today to teach you how to graph systems of linear inequalities. As you recall, we spent the last couple days graphing just one linear inequality on a coordinate grid and a number line, and now today we're going to do a system of linear inequalities. So here we go. Our first system, as you can see, is y is less than or equal to 2x plus 3. And the other inequality is 2y is greater than x minus 2. And as you already know, the rules state that we need to make sure both of our inequalities are in slope-intercept form. So our first one is ready to go. In fact, here's our coordinate xy axis, and y is less than or equal to 2x plus 3. We already know the slope. We already know the y-intercept, or the beginning point. So let's write that down. M is 2. Or you can write it as 2 over 1 as a rise over run. And our b value is 3. So we're going to begin here on the y-axis at 3. And then we're going to count our slope, rise 2, run 1, rise 2, run 1. And then we also can go in the negative direction for both, down 2 and to the left 1, down 2 and to the left 1 to finish off our points. However, before you draw your line, you want to make sure you're looking to draw either a solid line or a dotted line. And in this case, we have less than or equal to, and so it's a sign here that says our line should be a solid line. So we're going to go ahead and draw our solid line. And then at this point, instead of picking a point to test at 0, 0, like we saw earlier in the week, we can actually just use the rule that states if it's less than, then we can shade below the line or down below our graph. And so we're going to shade below our graph, and that tells us that we have an infinite number of solutions that fall in this area. Now let's take a look at our other inequality. 2y is greater than x minus 2. And we need to get this in slope-intercept form. And it's actually almost there. All we have to do is get rid of the 2 times the y in front of the y. And in order to undo multiplication, we always divide. So we're going to divide each term by 2. And again, if you want to write 2 separately here, that's okay. That's how I write it in class. And we're going to simplify or rewrite this as y is greater than 1/2 x, because there is a 1 here, and then 2 divided by 2 is 1, so we keep the minus sign. And now we know our slope and our y-intercept. So m equals 1/2 and b equals -1. So we're going to begin here at -1 on the y-axis, and we're going to rise 1, run 2, rise 1, run 2, rise 1, run 2. And again, before we draw our line, we're going to look to see, is it going to be a dashed line or a solid line? And in this case, we have just a greater than symbol, which means I don't have to, or I don't have an equal sign underneath it. So it's going to be a dashed line. And what that means is we're not going to include any of these points along the line. It's just going to be the ones greater than. So we're going to be shading above. And if you'll notice, where your 2 intersections overlap, this dark red area, that is the solution to the linear inequality or to the system of linear inequalities. And that is the piece that we're looking at. So my suggestion to you is to use 2 colors, maybe red or yellow and blue that make green, so you can actually see the 2 colors overlap when you're taking your notes. Okay, next example. X plus 2y is less than 5. Again, that's not in slope-intercept form, so I'm going to need your help getting it there. My first move or my first step is going to be to subtract x, and then we're going to just drop everything like it's hot, rewrite it. 2y is less than -x plus 5, and now we're going to divide every term by 2. And so this simplifies to y is less than -1/2 x, because we have a -1 in front of x, and then just we're going to leave 5 over 2 as 5 divided by 2. Feel free to write it as a decimal if you so wish. And now I know my slope and my y-intercept. So we're going to begin at 5/2, which is actually 2 1/2. So we're going to be in between 2 and 3 here. Be careful when you're plotting that point. And now we're going to go down 1 over 2. And we're not going to go down just a half, we're going to go down 1 whole. So again, you're in between the coordinate grid here. Down 1 over 2, and we can also go in the opposite direction. So once again, before you draw your line, check to see my symbol is a less than symbol. There's no line under it, so it's going to be a dotted or dashed line. And then we're going to shade everything that is less than or below all of the solutions, all these coordinate points below my line. We're not including the points that are on the line itself because it's just less than. Looking at our second inequality, 3x minus y is greater than or equal to 4. And I'll give you a clue. When the y is a negative, we're going to have to do some flipping of the symbol. So the first step, I'm going to subtract 3x from both sides, rewrite it, cancel those out, and we end up with negative y is greater than or equal to negative 3x plus 4. And at this point, as soon as you see that you're getting ready to divide by a negative 1, we need to flip our symbol. So that's why I left a space here, so I remind myself that I need to flip this to a less than or equal to sign. And so now we just simplify, these cancel out, and y is less than. Now be careful, a negative divided by a negative turns into a positive, and a positive divided by a negative stays negative. So our new equation is y is less than or equal to 3x minus 4. So this tells me my slope is 3, or 3 over 1, and my y-intercept is negative 4. So we're going to begin here at negative 4, and we're going to rise 3, run 1. Rise 3, run 1. And we're going to keep going until we run out of room. And again, take a look at your symbol. It's a less than or equal to sign. So we're going to draw a solid line through our points. And notice it's less than, so we're not going to shade up. We're going to shade below the line. And boom, right there is your solution. All of these points in this area, and of course they're over here too. We just are only seeing a portion of our grid. All of these solutions are solutions to our linear system. Next example. Notice we have more than one. We have not done one of these where we actually have 3 linear inequalities, but this is definitely still an Algebra 1 concept. And notice our equations are not very complicated, very simple. One's horizontal, one's vertical, and one has a little bit of slope. So let's start here. This is sort of a review from yesterday. Y is greater than negative 2. That tells me I have no slope, or the slope is 0, and I'm just going to have a horizontal line going across it, negative 2, and it's a dotted line because it's just greater than, so I'm going to be shading up. And I think it's important here that you pick 3 colors so that when we see the overlap, we can see how they overlap with the 3 colors. My next inequality is x is less than 3. So we're going to go on the x-axis to a positive 3, and this time it's going to be a vertical line. It's also dotted or dashed, and we're going to shade all of the numbers less than. So that means to the left, to the left. And then our last inequality here is obviously with 2 variables. So that's going to have some slope or steepness, which means I need to get it in slope intercept form. And before I do that, or while I do that, by subtracting x, I'm going to pay close attention to this negative y. So now let's rewrite it. Negative y is greater than or equal to negative x minus 4. And again, before you divide by this negative, pay close attention to flipping that symbol. That's the exception when you divide or multiply by a negative number. And here we are. Greater than or equal to now becomes less than or equal to, and 2 negatives cancel out, and we end up with y is less than or equal to x plus 1. And again, 2 negatives divided together make a positive. 2 negatives divided together make a positive. And now we know our m, which is our slope, and b, which is our y-intercept. So we begin at 1, y equals 1, and we already have a point right here at 1, and we're going to count our slope, rise 1, run 1, rise 1, run 1. and we can go in the opposite direction, down 1 to the left, down 1 to the left. And again, notice there is a line underneath our inequality, which tells me it's a solid line. And I'm shading less than. So I don't need to test a point because I know the trick here. Less than means shade below your line, and boom, right there in the center is your solution. It makes a beautiful triangle. And again, if at first you might have thought 3 inequalities was going to be difficult, and you can see here we have a nice solution here in the center. Okay, last one before we work backwards here. Again, neither one of these are in slope-intercept form, so I need to write them in slope-intercept form before I begin graphing. And most of you are getting good at this, so we're going to subtract 2x from both sides, rewrite it, drop everything like it's hot, and now we're going to divide by 3. And now we have y is greater than negative 2/3 x plus 2. And again, you can see negative 2/3 and then 6 divided by 3 is 2. If you want to write those separately, as I suggest, feel free. And now I know my m, which is my slope, and b, my y-intercept. So if b is 2, I'm going to begin here at 2, and I'm going to go down 2 over 3. Down 2 over 3. I might run out of room here. I can also go up 2 to the left 3. And then again, this is going to be a solid line shading up. Solid line shading up because it's greater than. And then our next equation, subtract x from both sides. Drop everything like it's hot. Negative 2y is less than negative x plus 2. And right here, ding, 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 I'm going to be dividing by a negative 2. So that tells me I must flip my inequality, flip my symbol. And so now when I simplify this, this is going to be y, these cancel out, is greater than a negative divided by a negative is a positive, and there's a 1 here, so that's 1/2 x, and a positive divided by a negative is a negative. And now I know my m and my b. So begin here at negative 1, and we're going to count our slope, rise 1, run 2, rise 1, run 2, and we can also go in the opposite direction, down 1 and to the left. And of course, because we have just a greater than symbol, there's no equal to under it, it's a dashed line or a dotted line. And we're going to be shading up. And there is our solution. Where our two colors overlap or our two solutions overlap, that is the solution to the system of linear inequalities. And I recommend maybe pausing the video before you start this example and actually try this one on your own and see how you do. Okay, last but not least, I want to work backwards here because I want you to see here when we write a system of linear equations, given the graph, we're kind of working backwards. So notice these are both vertical lines in number 1, so this should be really easy because they're going to begin with x equals or x is less than or greater than. And so we'll start here with the one on the left. It is a dotted line at x at negative 3, and we're shading to the right, which means it's any number greater than negative 3, not including negative 3. So our inequality looks like this. X is greater than negative 3. And now the one on the right-hand side is at positive 2. X is positive 2, but it's solid. So it means it includes 2 and anything less than 2. So we're going to say x is less than or equal to 2. And that's it. Number 2, these both have slope or steepness, so we know we're going to be writing them in the form of y equals mx plus b. And so here we go. Let's start with the solid line here. We're beginning at 1, and we rise 1, run 2, rise 1, run 2. So that tells me that my equation is going to be a slope of 2x plus 1, or 2 over 1 if you want. You can write it that way, plus 1, because I began at 1. And then, of course, it's a solid line, and we shade it up, so it's greater than or equal to. And the last one here, at beginning at negative 2, we go down 1 over 1, down 1 over 1. So that's a negative slope of negative 1x. If you want to put a 1 there, that's fine, minus 2. And our symbol that we're going to use here is a less than.